This is applications of the Vertex formula. So we're going to be given formulas with quadratics, and we already know that when we graph them, they make parabolas. They could be upside down parabolas or right side up. And these are always when our a is positive. And then when our a is negative, they're upside down. So this one's negative, so we know it's going to look like this. Okay, so read the question. And then now we're going to define our variables. So we have two. We have P, and this is the price. It's in dollars. And we have the revenue, R. And it's also in dollars. So if we want to find, right here, for what price will the daily revenue be maximized? If we're looking for the maximum, that's our Vertex formula. It's not an X here, it's a P. So we plug it in. Negative b over 2a, so 600 over 2 times negative 5, and that gives us 60. So the price that will maximize our revenue is $60. See, what's happening is as we increase the price, so here's a little x and y axis here, so as we increase the price, we're making more money. Even though we're not selling as much, we're still making more money. But eventually you hit a point where the amount of increase in price is not justified because we're not selling enough, so the revenue starts to go down, and that's what we're looking for, our maximum revenue, and that's the Vertex. So if you see the word maximized, use the Vertex formula with a quadratic. It'll give you your x coordinate. And so that's your P. That's the value of P that will maximize it. Now what's the maximum daily revenue? Well, now we need the y coordinate. We need the R at that value. So if we plug it in, plug in the 60, we get negative 5 times 60 squared plus 600 times 60. 18,000. It's a lot of money for one day. So $18,000 is a daily revenue. So if we're trying to maximize our y value, our r in this case, then we use the Vertex formula to find the p or x value that when plugged in will maximize that value. So that is the biggest amount of revenue you would get at the Vertex. This is for quadratics. So let's try another. This is pumpkin chunkin'. And so they're going to shoot stuff off of a catapult. And when you do, it has this shape, right? Parabola again. So right here, this would be our maximum height. Get the idea? It's the same basic principle. So if we use the Vertex formula, it'll give us the t, the time, that gives us a maximum height. So read the question, and now label your variables. So s is our height. So if we want the maximum height, we need a value of t to find s, and then t is time, and the time will be used to find that maximum height. So determine the time at which the pumpkin is at the maximum height. So we use the Vertex formula to find our Vertex. Negative b over 2a. So negative 96 over 2 times negative 16. Plugging that in, we get 3. Let's just check it. So 96 divided by 32 is 3. Yes. So 3 seconds. After 3 seconds, we'll be at the maximum height. So you can literally count it off as 1, 2, 3. 3 seconds. And that's the trajectory. So at 1, it's here. It's 2 there. 3, it's at the maximum height. And then it starts coming down. So if we want to find that maximum height is s. So if we plug in 3, plugging all that into your calculator, we get 152, and height is in feet. So the pumpkin's starting at 8 feet, and it just keeps climbing and climbing and climbing off the catapult until it hits 152 feet, and then it's coming down. And that's everything. Thank you.